Hello! Now, in case you were thinking 4.3 was way too easy. Well, it was. It can't possibly be that easy. So, we're going to try something a little more tricky here. So, this is what I'm calling 4.3.1. And this is problem number 1. Now, let's see how this works. All right. You know you're in trouble now. So, imagine, if we will, that your pet, which in my case is a chicken, there it is, there it is, there it is, there it is. It's got wings, it's got feet, but this chicken, lucky fellow, is no ordinary chicken. This chicken is about to become Astro Chicken. Yes, this chicken is sitting right on the top of a fairly powerful rocket, which is going to have a lot of flame coming off the bottom as it launches up into the sky. Now, how's this going to work? Well, here's how it goes. The rocket pushes up with a force of 300 newtons. Now, the rocket's pushing the chicken, but that's also pushing the rocket. The rocket is 10 kg. The chicken is not 10 kg. The chicken is 3.2 kg. Now, by the way, your rocket will be the same, but you don't probably have a pet chicken, do you? Your pet's going to have a different mass. And you're going to find that mass in your biometric page. So here we go. F equals M. Well, my M is going to be the sum of 10 kg plus 3.2 kg, because they're both going up together, times the acceleration. That's what we're finding, right? Force was 300, right? And you're probably thinking, well, that's pretty easy, isn't it? 10 plus 3.2 is 13.2 kg. Multiply that by A, and we're in business. But we've been kind of simplifying this, haven't we? We left something out of Newton's formula. We left that out, the sigma. The sigma means it's the sum of all forces. Yes, the rocket is pushing up with 300 newtons, but something else is going on. This rocket is taking off from Earth, the home of all chickens, and Earth has gravity. Well, gravity is pulling down. So the force of gravity is equal to mass times acceleration, 9.8. But again, we have a combined mass. So, allow me to erase this chicken's tail. No one needs a tail in space. There's no air. So, the force of gravity, which is pushing downward, is going to be the mass times 9.8. That'll be 9.8 times the mass of the rocket is 10. Ding dong, ding dong, ding dong. The mass of the chicken is 3.2. Your animal, of course, is different. And that direction is that way. So we got the rocket goes up, the weight goes down. So let's start doing math. 9.8 times 10, 10 plus 3.2 is 13.2. And the direction is still down, plus 300 newtons up. And again, that still equals 13.2 combined mass of chicken and rocket times A, right? So 9.8 times 13.2. Hey, guess what? I wrote it down already, huh? So I'm getting 9.36 newtons down plus 300 newtons up. equals, again, 13.2 kilogram times A. What we're trying to find at the end is A. Now, we got a problem. These are both in newtons, but one is up and the other one is down. Now, we can fix that. Here's how we fix that. Would you say that we could switch this? We can make them both up by making this a negative. Now they're both the same direction. This is negative this direction, and this one's positive this direction. But they're both in the same direction, and we can work with that. So, negative 129 plus 300 gives us roughly 170 point something 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 newtons. Let's see, it's 170.64. Yeah, 64 newtons. So, that is newtons, and the direction is upward, right? And that equals 13.2 kg times the acceleration, the thing we're always trying to find, right? So, divide both sides by 13.2 kg. Come on in. I'm almost done. All right, 13.2 kg cancels itself out. 170 divided by 13.2, and you get 12.927 meters per second squared. And that's equal to A. Oh, and acceleration is upward. Now, that's not your answer, by the way. The reason why, all these calculations rely on one thing. 9.8. And that's an issue. We're not going to have anything that's more than about 2 sig figs. So your final answer, A, is equal to 13 meters per second squared in the up direction. Hope you can see that. If you can't, it's A is equal to 13 meters per second squared up. Now, use a little math sense. Everybody's rocket has the same mass. Everybody's rocket has the same thrust. The only thing you're going to have different is you're probably not going to have a chicken. So, your mass of your pet, if it's larger than a chicken, will be a bigger mass. Now, bigger mass means more weight. More weight means that the sum of the forces are going to be smaller, which means you're probably not going to accelerate that fast. If your pet's a pony, you might not accelerate at all. You might find the rocket just doesn't have what it takes to lift a pony into space. Sorry, Rainbow Dash. Anyway, now you know. Any questions? Please let me know. Let's see, can you see that? Yeah, now you can see the bottom. Okay. Everybody see the bottom?